Okay, so today we're going to review chapter 8. And in chapter 8, we're talking about sampling distributions. Whoops. There we go. Okay, so I want you to recall back to step 1 when we first addressed sampling distributions. And remember what we're doing with sampling distributions. We're looking at multiple samples to learn about the random variable. And remember what that is. That's my sample mean, X bar, we're trying to learn about, or the sample proportion, P hat, is what we're trying to learn about. So I'm going to break this into two different topics. I'm going to break it into the sample means, which is my numerical data first, and then we'll discuss the sample proportions, the categorical data, and then we'll look at some examples. So let's take a look at the sampling distribution. Of the sample means, and that is my X bar. Okay. So remember here, first of all, my sample mean is represented by X bar, and this is my numerical side. So X bar is for my numerical data. So what we want to do is we want to describe the sampling distribution. Of X bar here, of my sample means. And the way we're going to do this is by looking at shape, center, and spread, just like we did last class. So, and which you probably have done all through step 1. So the first thing I want to look at is the shape. And if you recall back to step 1, when we were looking at the shape, we always wanted to be able to say it was normal, right? The reason why we wanted to do that is the same reason as last class, is that that's what we're calculating probabilities or percentiles based on our normal curve. So we need to be able to say the shape is normal. And if it's not, then we can't go ahead and calculate those probabilities, and that's fine. It's just we want to be able to show that if we can, right? So, I mean, we don't want to just make it up. We want to make sure it's true. So for the shape, we want to be able to say, is it normal or not, right? So that's what we're asking ourselves. Is it normal? Is it symmetric? Is it bell-shaped? That's what we're looking at. So we have 3 different ways in this chapter of being able to tell if a distribution is normally distributed. So if it's bell-shaped or symmetric. The first way is that you are told that the population is normal. So recall back to step 1 that if our population is normal shape, then our sampling distribution also follows that normal shape. Remember, we're taking all distinct samples of size n. So there's a lot of samples for the population, whatever the population may be. Okay, so if we're told, this is the only scenario that will be told that the population is normal, because remember in chapter 8 is the only time that we actually know anything about the population, because in chapter 8 we're kind of working backwards, where we know information about the population, we're trying to find out information about the sample. So it's kind of unrealistic, right, this scenario, because it's normally the other way around. We're trying to find out something about the population based off of a sample that we have, right? So this is just kind of working backwards. It's just setting us up for the rest of the semester here. The second way to tell that it's normal is that the sample size is greater than or equal to 30. And this is from our central limit theorem. So this just says the central limit theorem just says that if our sample size is greater than or equal to 30, then the sample is what we consider large enough to produce a symmetric data set of all these sample means, okay? No matter what shape the population is. So for this one, it doesn't matter. Maybe the population is skewed right, but if my sample size is 30 or larger, then I'm still okay because that sampling distribution will come right back down to a normal shape. Okay, so that's one way. And remember, we don't need all three ways. We just need one thing to be able to prove the shape is normal. And the last way is the NPP. And now we're going to take it that step further that we talked about last week, which is that normality test. Okay. So normally if we are going this route, the NPP and the normality test, this normally means that N, I'm just going to write it here, it just normally means N is less than 30 because we're always going to use option 2 if we can, right? We're going to go that route because it's an easy visual. So if N's less than 30, we can't go with option 2, and maybe we're not told, so we can't go with option 1, but maybe we have raw data. Then we can go with this third option. So we have to have raw data to do the normality test because we can't get an NPP without raw data. Okay. So that's how we're going to tell the shape is normal for these sampling distributions. Okay. And then the next thing we want to be able to look at is the center. So for my center here, my center of my sampling distribution, it's the mean of all these X bars. So it's all these X bars, and I'm taking the average of all of those sample means, and that comes right back down to the population mean. Okay. So let me just write that over here to the side. I'm going to say the mean of the sample means equals the population mean, which is mu. Let me put that in parentheses, mu, my population mean. So that's the center of my curve. And the spread of my curve, I want to get this all in one sheet. So that's why I'm kind of squeezing this in here. The spread of my curve, so this is the spread of my sampling distributions. Remember, this is the standard error. And I don't just say standard error, I say standard error of X bar. And the reason why I want to make sure I distinguish X bar is because on the next page, when we talk about proportions or categorical data, it's going to be p hat, right? So we want to know the difference. And all this is the standard deviation of all of my sample means. It's the standard deviation of all my X bars, which this comes down to the calculation of my population standard deviation divided by the square root of N. And I'm going to write that down. So this is the standard deviation of the sample means. And that is the standard error. So this is where we first are introduced to standard error. Okay, and standard error is just the standard deviation. It's just the standard deviation of all these X bars, right? It's no longer just of data values. It's of a whole bunch of sample means. Okay, so that's why now it has a new name. Okay. I want you to take a note, or I'm just going to mention it real quick now, and I will show you, of course, in the example. Minitab will ask for standard deviation, but what I want you to know is it's asking for the spread of the curve, and for this type of curve, it's the standard error. Okay, I want you to know that. I just want you to keep that in mind, and I will, of course, mention it again when we're looking at the example. So I'm just going to kind of name these. So let me just name this, although I know I already did it over there. This is the population mean. Then there's no confusion. This is sigma, that is my population standard deviation. And then N, remember, is my sample size. So just get that all in there. And then that way I'm gonna zoom in, you guys can see it a little bit better. Just to name those and kind of identify what those symbols stand for, in case any of us forgot. If you just took stat 1, you probably didn't forget, but if you took stat 1 a while ago, you may have forgotten. I try to always have like a little key. Okay, so this is my sampling distribution for and how to describe it for my sample means, my numerical data, X bar. Okay. Remember, guys, I'm always going to scan these notes in and they're available after class, and I can always pull it back up. I don't mean to like move it too fast. I just want to keep moving. All right, so now let's do the same thing and we'll take a look at our sampling distribution for categorical data. So, oops, wrong color pen. Grab the wrong one. I don't want to write in red a whole bunch. So, sampling distribution of the sample proportions. And that is P hat. Okay, my sample proportion is P hat. Let me just write that here. My sample proportion is P hat. This is for my categorical data. Okay. So let's go ahead and describe the sampling distribution. So again, we're going to start with the shape of the distribution, and the same thing as before. I really want this shape to be normal. I'm hoping I can prove that it's symmetric, so I can go ahead and use that normal curve. So here for proportions, we only have one thing that we can do for this one, and that is showing that n times p times 1 minus p is greater than or equal to 10. Okay. So what we're looking at is we want to make sure that that population proportion, so let me write a little key over here. So n is my sample size, and p is the population proportion. And then, so remember when we're looking at proportions, it's the percentage of successes. So remember categorical data is if you fit in a category, it's a yes, no question. So when we're looking at proportions, P represents that the amount of proportion or the percentage of people that fit in the category that we're studying. So answered yes to the question. And then 1 minus P are the other people. So it's the people that answered no. So this is my success rate is P, and 1 minus P is my failure rate. It's not that it's a right or wrong. It's just what I'm interested in, right? It doesn't mean just because someone answered yes that that's the correct thing. It just means that that's what I'm interested in. So we only have this calculation. Remember, for sampling distribution again, we have information about the population, and that is why we have P, right? And we're trying to see what's going on with P hat, right? So that's why we have that. So here, now let's talk about the center, and it's very similar to the numerical side of things. So for the center, it's the mean of all the P hats. So I'm going to take all of my sample proportions and average them, right? This will come right back down to P, because remember, when I'm looking at this, I'm taking all distinct samples of size n. So when I take the average of all those sample proportions, it should come down to my population proportion, okay? So let me just write this. Just give like a little explanation here. So the mean of the sample means, or I'm sorry, the sample proportions is equal to the population proportion. I just remember when we get into these proportions and categorical data, we have a lot of P's, right? We have P, the population proportion, P hat, the sample population proportion, or the sample proportion. And then all of a sudden we get into P value for probability, and then just capital P for regular probability. And we get into all of these. So I'm hopefully they're not getting confused or by you, okay? Or maybe I'm not telling you this in a confusing way. All right, let's take a look at the spread of this curve. So when I'm talking about the spread of this curve, I'm talking about the spread of the sampling distribution for my p hat. So when we're looking at the spread, it's the same thing. It's the standard error because I'm not looking at just single data value. I'm looking at a whole bunch of samples, right? So it's my standard error of my p hats, okay? So I want to make sure I distinguish the difference between the p hats and then over here when I had the x bars, okay? So when I have categorical, it's for p hat. And the calculation for this is the square root of p times 1 minus p divided by n. That's all under the square root. So over here, I'm just gonna, I guess I probably don't really need to write it again because it's up here. N is sample size and p is population proportion. Okay, that's what these all represent down here. Okay. Let's just write SE is standard error, which is the standard deviation of the p hats, right? So it's how spread out are all those p hats. So what I want to do here, I want to go ahead and take a look at an example, and we'll walk through some Minitab and the write-up and everything that I expect to see. So for the example I want to look at is example number 1, and this example is on page 5. So I'm going to switch over here to my typed notes, possibly. Okay, there we go. It wasn't working. So we're on day 3. So these are the day 3 typed notes. I already had them downloaded. Remember, I always recommend that you download the typed notes because they are skewed if you leave them in the web browser. So I downloaded them and opened up the Word file, and I went down to page 5 already. I just had us all prepared here for this. So we can take a look at this example. So remember, some examples have a little bit more meat to them than others, meaning more context or more meaning behind them. And sometimes you'll just see some numbers. Sometimes if you just have an example for numbers, it's just so you can get used to the idea of Minitab, and then you add context to it. This one has some context, but it's not you don't have like a whole story. So all it says is that sales figures fluctuate around a mean. Now, off to the side on a piece of paper, I'm going to write this down. I'll show you after. I'm just going to write this down. So I have it. So I like to have all my information written down. If this was in front of me, I would just circle everything. So my mean is 500, and the standard deviation, so that's my sigma, is $300. A random sample of 36 days. So that's my N. My N is my sample size. So it's saying that I have a sample size of 36 days sales figures is taken. So we don't really have a lot of information. There's a little context to this problem. So that's what I'm saying. Sometimes for these first examples, we don't have a ton of context. It's just nice to work through the problem with the numbers and not have to worry about too much.
Professor, the mean is actually 900.
Oh, thank you so much.
No problem.
I wrote down 500. Thank you so much.
No problem.
Everything up. I appreciate that. So when I'm looking at this, it says in part A, describe the sampling distribution. So now it says shape, center, and spread. So anytime you see something that says describe the distribution, and here it's specifics, it's sampling distribution, they always think shape, center, and spread. Okay? So when I do this, I'm going to stop sharing this and then we can go back to this. I just want to show you this. Okay, so here's my example one. You can see where I wrote 500. Now I corrected that with the 900. My sigma is 300 and my n is 36. So for part A, to describe the distribution, the shape I have either one way if it's categorical or three ways if it's numerical. What type of data do you think this is, guys? If I'm given a mean and I'm given a standard deviation, first of all, do you know what kind of data this is? If it's a mean and a standard deviation, it's numerical data. You will not be given these two things if it was categorical data, right? If it was categorical, you'd be given a proportion. And then if you look at the context of the problem, which there wasn't much, it says sales figures. Sales figures are numerical. So I'm just going to make a note over here to the side that this is numerical. I need to know that first, because how can I describe a distribution if I don't know what type of data I have? So it's numerical. So in that case, I have three different ways to say that this is normal. And I don't want to say it's normal unless it truly is normal. Right? So I'm kind of asking myself this question, is this normally distributed? So if we go back to our notes and look at the three different ways here, we could be told the population is normal, and we definitely were not, because we were given like one sentence. We had very little information. The sample size is greater than or equal to 30, which it is, right? N is 36, so I can go ahead and use that way. So you can write it different ways. You could just say n is greater than or equal to 30, like a little check mark, normal. So I want you to tell me, I want you to say that it's normal, and I want you to explain to me why. So right here, n is greater than or equal to 30 is explaining to me why you're saying it's normal, okay? You should never just come to this problem and say it's not normal, okay? We don't know how to prove that it's not normal. We just know how to prove that it is normal. So if we can't prove it, then you would just say, I can't tell if it's normal or not, right? We don't know. If n was less than 30 and we had raw data, we would go on to option 3 and do our normality test, but we don't have to worry about that.
In this situation, would you want like full sentences? I know right here we're just putting like a notation. Okay.
No, just like this is fine
Perfect.
for me. I'm good with this. Yeah. Yeah, thanks for asking. So now I have my shape. I can go on to my center and my spread. So for the center, remember the center here, we're looking at the mean of all the X bars, but I'm not actually going to calculate all the X bars and take the average of those. I'm just going to go ahead and state that it is equal to my population mean, which my population mean is 900. So 900 is the center of my curve. At this point, you can go ahead and start drawing a curve if you wanted to get a little visual. You're just going to put right at the center 900. I might do that in just a minute. But let me take a look at the spread first. So the spread, remember, is no longer 300, the standard deviation. The spread is now the standard error of my X bars. And that comes from the standard deviation divided by square root of n. So that is 300 divided by the square root of 36 there. Okay. So here, my standard error of my X bars should be 50. So if I'm going to look at a drawing of the picture, which you don't have to, but I often do this, I have a center at 900. Really at this point, the drawing doesn't do a ton for me. It just gives me an idea, okay, I have a symmetric shape, the center's at 900. Where this is gonna come in handy is the second part, part B, where it actually asks me a question about this problem. It's just, this is basically the drawing to go with what we just did. I just don't really do much with the spread on here quite yet. All right, so let me share my screen again so we can see what part B is asking us. So in the day 3 notes on page 5, in part B, it says if a random sample of 36 days sales figures is taken, what is the probability that the mean sales figures are less than 875? So I'm just going to write this down. I'm going to stop the share. So it says, what is the probability? So that means I have a capital P, that the sales figures is less than. So X is less than 875. That's what we want to know. So 875 is less than 900. So I know it's over here someplace. It's just a sketch for you. It doesn't have to be specific, right? If you know your spread is 50, it kind of gives you an idea, right? One standard deviation would be 850, right? Then 800, and 750 would be 3 standard deviations away. And that kind of gives you an idea, but it doesn't, this is just your own sketch. It's not for me. We're doing less than, so it means everything to the left. Remember, Minitab's going to give me everything to the left, so I won't have to do any extra work on this problem. Okay, everyone good with that? So now I have my drawing and I have my notation. I can go ahead and open up Minitab and hopefully work through the steps to get this value, and then I can put it into words. And we're going to do the same thing as we did last class with the Minitab steps and how to put it into words. It's just the only difference is now my spread is no longer the standard deviation like it was last class. It's now the standard error. That's the difference here because we're working with sampling distributions. So I'm going to share my screen. If you want to follow along on your own computer using Minitab yourself and trying it out as I walk through it, feel free to do so. That's fine with me. But I'm going to show you here. And remember, I don't have a Mac. I'm using Windows. So what you see here might be different from yours if you have a Mac, but I will try to mention the Mac steps along the way. So no matter what type of computer operating system you're using, you're going to go to the menu bar at the top and choose Calc. And from there, you're going to choose probability distributions. Now for me with Windows, I have this big menu to choose from, and I'm going to go all the way to the top and choose normal. If you are using a Mac, from probability distributions, you only have 3 options. And from there, you're going to choose cumulative probability. I just want you guys to keep in mind, I'm choosing the same thing. It's just after I choose normal. See it right here? So if you have a Mac, you have these 3 options here. And I have to choose normal before I get those 3 options. That's the difference. We're all choosing cumulative probability because we're calculating a probability. So when you get a problem like this, you need to recognize before you even get into the computer, into Minitab, if you have, if you're calculating a probability or a percentile. So are you looking for the area under the curve or are you looking for a data value? So I'm looking for the area, that's cumulative probability. If I'm looking for a data value, it'd be the inverse option. All right, cumulative probability. It wants to know mean and standard deviation. So this is what I mentioned to you in class. It doesn't know. This is the same place we went last class. It doesn't know now that I'm working with sampling distribution. It's just the same thing. So with the mean, all it wants to know is what is the center of your curve? The center of my curve is 900. And for the standard deviation, it wants to know the spread, right? So this is now my 50. So please don't make the mistake of entering 300 in here, because then you'd be calculating for a data value and not a whole sample mean. Again, you could do input column or input constant. And I'm going to just choose constant, so we just have one value, which was the 875, right? We wanted to know if the probability, if it's less, if the average mean is less than 875. I'm going to click OK. And then I get this number out, which is 0.308538. I'm going to stop sharing this screen here. And so over here, you can just see I wrote it down over here. So it just means the area under the curve here in blue is 0.308538. And I can write out my meaning of this, because I always want to put it into words. And it's so much quicker when you're typing it. But what I would say is with a mean, so, or you could say a center, right, of 900, And you could say standard error, or you could say standard deviation, or you could say a spread. So there's a lot of different words you can use here. Of $50, the probability that the mean sales figures, whoops, are less than $875 is this 0.308538. Okay. So it's the same write-up that we did last class. You include your mean, your standard deviation or standard error in this case, and then exactly what you have right here. Probability that a sample mean is less than 875 is that value. Any questions on that first example? So similar to what we did last class. It's really almost the same thing.
I have a really quick question for like the first sentence when we say with a mean of 900 and the standard 50. Do we have to say like $900 or like standard?
Yeah, you could. If you weren't being really specific, it would be dollars. Yep. Yeah, that would be really specific. Am I that particular about it? Probably not.
Okay, thank you.
But yeah, to be specific, it is dollars. Yep. Yep. You got it. Yeah.
If X is like greater than 875, do we put it in like a different thing for Minitab?
No, remember Minitab always just gives me this area to the left. So if it was,
yeah.
if this was a greater than, you would need this, right? So you would still calculate this area to the left and then subtract it from 1.
Okay, yeah, thank you.
Yep, you got it. So same thing as last class. The in between still the same thing. Yep. The only thing that's changing is that we're studying a sampling distribution. So my center and my spread. So it's really the spread is now the standard error. That's the difference from last class, really. All good questions. All right, so let's take a look at another example before I have you guys work on your own. So the other example I wanted to look at is example number 2. And this example is on page 8 of the day 3 typed notes. So let's pull that up and oops, I'm going to share my screen and pull that up, and then we can talk about it and write down some key pieces of information. So I'm going to get down to page 8. Remember, guys, that was on page 5, that example. Page 6 right here is the completed example. So you can see everything typed up nice and neat as well, although we just did it in class. You can see everything all typed up right there. So this is on, I swear, when I just use this, like so much slower. Okay, there we go. Example 2, page 8. So I'm going to write down some key pieces of information as I'm reading this. And remember what we did in the first one? We kind of want to have an idea of what type of data this is, because that's going to drive how I handle the problem. So it says 70%. First of all, if I don't even know the context and I just see it says 70%, I'm thinking proportions automatically, right? I should never have a percentage when I'm talking about means or numerical data. So 70% of all US web searches are through Google. If we randomly select 300 US web searches, I want to describe the sampling distribution, and then in part B, we're going to calculate something. So again, there's not a big backstory and you don't need it. We have enough information to move forward. And like I said, the 70% gives me that kind of, I don't want to say a red flag, but kind of that it's a proportion, categorical data. And it says of all US web searches are through Google. So the question here is the web search through Google, right? And it's a yes, no question. Yes, it is, and it fits in the category, or no, it isn't, and it doesn't fit in the category. So right there, it's categorical, okay? So just talk yourself through it if you're having trouble telling the difference between the two. And by the end of this class, you're gonna be a pro knowing if something's numerical or categorical, because we're gonna do it all of the time. So I'm just gonna kind of write it off to the side. It says 70% of all US web searches. So all of them, that is my P, that's my population proportion. And I'm going to write it down as 70%. And then I'm also going to say equals 0.70 because I'm working with Minitab, I need to think mathematically and I need to change percentages into decimals. Now it says if we randomly select, so that's my N, 300 searches. Okay. And now in part A, it says to describe the shape, center, and spread. So I'm just writing these down and I'm going to, I'm going to share stop sharing this screen and share my other screen and we can see. So I just wrote all my information down. P, my population portion is 70%, that's 0.70, N is 300. Part A says describe the distribution, so it's shape, center, and spread. So keep in mind here, I want to be able to say that the shape is normal and I kind of have to find out if it is normal. So here for proportion, so I'm going to write this down, categorical. So I know what I'm calculating here because that's going to drive how I do all three of these. That's where I'm going to use N times P times 1 minus P. And I just want to make sure that's greater than or equal to 10 in order to say that it's normal here. So for here, N is 300, P is 0.70, and then I have 1 minus 0.70. If you take the shortcut and write 0.3 here, that is fine. And that's greater than or equal to 10. If you've taken stat 1 with me, this is important for me to see, right? This part. Not just saying, oh yeah, that's true. I'd like to see this part because I like to see what value of P you're plugging in because as we move forward through the class, it can change depending on what we're looking at, okay? So it's important for me to see this, that 0.7 in there. So yes, it is. So this step is not necessary, but you can actually say what all of this is multiplied out. It's 63. Yes, that's greater or equal to 10. What I mean why it's not necessary, this part, and I'm just gonna box it in because this is what I really like to see. This is what's important for me, okay? And then you can just say, yes, normal or check mark, normal. So you're saying it's normal, and then here you're backing it up. This is how you're saying it's normal, okay? That's what I'm looking for. So if you just tell me it's normal, it's not enough. I need to have that backup. So for my center, I'm looking at the mean of all my P hats, but remember, I'm not actually going to find all the sample proportions and then take the average of them. We just say it's equal to the population proportion, which is 0.70. And for the spread, I'm looking at the standard error of the P hats. And this is a fairly quick calculation of P times 1 minus P divided by N, all under that square root. So here, I'm just going to plug in here. So the square root, so I have 0.7, 1 minus 0.7 divided by 300, all under the square root. And here I get a fairly small number, 0.026457513. Now, in stat 1, I would have definitely rounded this a lot more. In stat 2, I actually leave it out a lot further. If you rounded this to 0.026 and then I kept it with this many 9 decimal places, then you might see a slight difference in your answer and your probability. So I actually like to use a lot. Now, if you've had class with me before, I always allow for, like, if someone did it this way and rounded to 3 decimal places, then I would calculate the answer based on that for like a test for grading. But I try to leave it out as far as I can so I can get a more accurate answer. Remember, rounding just kind of leads to a less accurate answer. And we kind of just take that chance when we round. Okay, so that's describing my distribution. I can draw a picture at this point if I want. A picture isn't really going to do a ton, but I can draw a picture. It's normal shaped and at the center is 0.70. And I can't really do too much with the spread on this until I get to part B. So I'm going to share my screen again and take a look at what part B asks for in the day 3 notes. And so part B says, if we randomly select 300 US web searches, what's the probability? So I'm just going to go ahead and write this down. What is the probability that more than, the X is greater than 0.72, 72%. Okay. Remember, it's always what we're interested in is if they're Google searches. So I'm going to stop sharing this. Sorry if that kind of gives you guys whiplash going back and forth so much. So I want to know the probability that my random variable is greater than 0.72. So 0.72 is greater than 0.7. It's actually fairly far away if you take your spread into account. So I'm going to put it here. It doesn't really matter. It's a drawing. It doesn't have to be specific. So there it is. And I'm going to shade in the greater than to the right. So this is one where I actually have to find the less than, so everything to the left of 0.72 and then subtract it from 1. So let's just remind ourselves that this right here, the greater than, is equal to 1 minus the probability that X is less than 0.72. So you always relate it back to the less than, and I'm going to do that by subtracting this probability from 1, which is my total area under my curve. So let's go ahead and take a look at Minitab and see what we come up with. So remember Minitab, I'm going to use the same function as I did before, even though I'm looking at categorical data. So I'm going to go into Calc, probability distributions. Again, if you have a Mac, you're going to choose the cumulative. And for me, for Windows, I'm going to choose normal, then cumulative, which it just defaults to, so I don't have to click on anything. The mean has changed because the mean is my center of my curve. The center of my curve is what we already stated, which is 0.70. The standard deviation, we are looking at standard error since it's a sampling distribution. This is where I'm going to type in 0.026457513. And again, I'm just going to look at input constant because I only have that single data value I'm interested in right now, which is 0.72. Okay. So I'm going to click OK and find out what we get. All right. So I get for the less than, I'm just going to write it down, then I'll share my screen, 0.775154. So I'm going to write this down here, and I'm just going to show you. So the greater than is 1 minus this value, right? This 0.775 is right here, this area to the left. I want to know the area to the right. So I'm going to subtract it from 1, and I find it to be 0.224846. So the area over here on this right side is the 0.224846. Here in the green, and that's what I was solving for. The probability that X is greater than 0.72. So again, I would write it out very similarly as the last example. I would say with a mean of 0.7, or you can say center if you feel more comfortable with that, and that's fine. And a spread of 0.026457513. You could say the probability that that more than 72% of the web searches, the US web searches or Google is 0.224846. I'm just going to share my screen and show you that write-up. Since I didn't write it down, remember it's always on the next page. So I'll scroll down here. You can see everything from part A, but right here is part B. And this is what we're always going to do. We're going to support what our write-up is with Minitab output. On a daily assignment, I almost always say include Minitab output. If you're not sure, you can always ask, or you could just always include it if you're not sure, but it's rare for me to not want the Minitab output. So, and remember with the Minitab output, it will confirm your center and your spread, right? So right here, And you can see the write-up. Okay. Let me switch this thing around.